InterGeo is a premier event where the industry that use geospatial equipment come together, and it's very much a technology-driven place. So we at Intel are investing in unmanned aerial vehicles or drones, and drones are quite in many ways used for commercial inspections as well as surveying and construction. The customers who come to InterGeo are the customers who actually use this kind of equipment for very, very detailed commercial applications. So at InterGeo, we actually announced for the first time the Intel Falcon 8 Plus. It's a commercial drone. This was meant for the North American markets, and we brought it and we showed a live demonstration of it here at InterGeo. This drone is actually sitting right behind me, something I would like to talk to you about and explain it. What are the unique features of this system? Intel has been working on drones for a couple of years now. And primarily, if you look at drones and what you think in the future, these are becoming more and more autonomous. In some aspects, you can look at it as they're becoming very much a flying computer. The drones, as they come into the skies, you want them to be very safe. So you want to have collision avoidance. We at Intel have RealSense technology. It's basically a sensor that's this small that we use. It's only 8 grams, but this provides capability to develop collision avoidance and not hit into objects or into cars or into bridges or into people for that matter. And it's a fundamental capability we think that help bring into the drone ecosystem and make them safer. Now, as you look at more and more, it's drones today, people look at it from a wedding, they take photos, they take videos, but if you start to look at where drones can be applied, the areas for commercial applications are phenomenal. Inspecting a bridge, inspecting a tower, inspecting, after a natural disaster, the damage that's done to buildings. There's a lot of human intense work, and in some aspects, it's even unsafe for humans to get there. Drones can do this at much quicker, much faster, and capture a lot of data that needs to be digitized. So these drones have payloads, and payloads include high-resolution imagery, they include infrared sensors, they include thermal sensors that can look at night in some aspects. They can also have multispectral. They can even tell you whether a plant in a field, in an agricultural land, is healthy or not. So there's many, many capabilities that these information from a drone can be applied. They need to be processed. You're talking about gigabytes of data. One drone flight could give you up to 50 gigabytes of data that needs to be processed in the computers. And then the people who use it are going to know, okay, what does it mean to me? So you have to go look at it and say, there has to be analysis done. They want to know whether a bridge needs repair. They need to know whether a tower needs some repairman to go and fix. So to get that information, the computers can help process these faster. So you look at that aspect of it from Intel, we look at the capability that the drones bring is the need for a huge amount of compute, processing. That actually helps the common man, because these are things that you want it safe. You want our infrastructure to be safe. You want our buildings to be safe. More we can inspect, we can not only understand what the issues are today, over time to be able to predict when can damage happen. If you look at the drone aspect and the drone ecosystem, one of the key aspects is how regulations allow you to fly. So governments and countries have different regulations to come in, and as of now, there are countries that see the value and the potential. You're looking at, like, over the next decade, over $25 billion of opportunity just by using drones from an economic standpoint. And United States, for example, just announced the Part 107 rule that gives permission to fly for commercial inspections. So we see that across the world, including countries like India, where a lot of these capabilities can be applied, that this, regulations are opening up. More and more governments understand the value it brings, and it opens up jobs. It opens up new usage models. and also digitizes information in a way we can use in the future. I think FAA is moving a lot more faster now in the recent history. The 107 rule is very well defined, but even if you look at 107 rule, the part 107 is still about visual line of sight, which means that an operator has to see where the drone is. Over time, I think the rules will start to become more relaxed, where you can fly beyond where the operator cannot even see, and start the journey towards full automation. AUVSI, which is actually the agency that actually put that study out there, said the economic potential of over $80 billion over the next decade, looked at the different applications. In many cases, like for example, a bridge, and you know, in the US alone, there are 600,000 bridges, on road bridges we're talking about. And inspecting a bridge is a very complex exercise. And as these infrastructure age, it is more important to know their health. And you need to have more frequent inspections. And it is definitely not possible and humanely possible to have that level of scale to do this on a regular basis. But a drone, on the other hand, you can have many of them inspect this at a short, fast, quicker time. And this itself is an economic opportunity. You're saving time, you're saving costs, and creating jobs. So, and by the way, this kind of a problem is not unique to US alone. In every country, this infrastructure and the inspection of infrastructure, for example, is a key requirement. Privacy is a very big aspect of it, and people look at drones and say, wait, is it capturing my private data? You have to look at it from a different aspect of how the data is used. Privacy is very important. We have to respect privacy, and I think there's already techniques on how privacy can be addressed. But here, you have to look at that the data that's looking for is not about the person there, or about some aspects of more sensitive information. You're trying to abstract it. You're trying to abstract it to a problem, like if you have a crack in a building, or if you have a bent pipe. This is a very different application, and yes, when you take data to capture for that, you're not looking at, yes, there may be people around it, but the idea is not to focus on the people, but to focus on the inspection, for example. So it is important that privacy is respected and maintained, and the applications and the software take handle of those concerns and appropriately have the use of the information.